we are going to learn about something very important and really interesting about chemical reactions. We've been doing and learning chemical reactions right from grade 5. And why are we learning about chemical reactions? Because we know that in our day-to-day life also so many chemical reactions keep on taking place inside our body, outside our body, everywhere. Without chemicals, there is no life. So chemistry is our life, chemistry is our love. And the topic that I'm going to take you through today, the introduction topic, is nothing but the chemical kinetics. Okay, now first question that will come to your mind, and I will also put forward, what do you understand from chemical kinetics? The first word is very simple, pretty simple, chemical. Chemical means we are going to discuss about chemicals. So what are the chemicals? Maybe your sodium chloride, ammonium chloride, potassium hydroxide, sulfuric acid, any chemical, proteins, enzymes, these all come under the list of chemicals only that we are going to discuss. We discuss basically in our day-to-day life. So the first word is pretty simple. We are going to study about chemicals. The second word states kinetics. Now what do you mean by kinetics? Kinetics meaning that we need to understand how the different chemical reactions take place, or how do the chemical reactions occur. That is what we need to understand first of all. So before I proceed with helping you with what do you mean by chemical kinetics, actually you also try to ponder upon it and get me the answer quickly. In the meantime, let us see what is the objective of learning this particular chapter. The main objective is to understand the average rate and the instantaneous rate. I'll explain you that as well. What is the difference between average rate and instantaneous rate, and how do you find that? Okay, we are going to look into this chapter the rate of reaction, how to express the rate of reaction in terms of change in concentration of the reactants or the products. We know that when a chemical reaction takes place, whenever a chemical reaction takes place, there is left hand side of the reaction, that is your reactants, there is right hand side of the reaction, that is your products. In short, that is the representation of a chemical equation. But whenever a chemical reaction takes place, we are going to take certain starting material which is called as reactant, and those starting material under the given conditions of temperature, pressure, probably catalyst involvement, all these temperature condition, pressure condition and catalyst involvement, they will form a particular product. The reactants have a set of properties and the product formed has a different set of property altogether. That is what is a chemical reaction. So we are going to express the rate of reaction. The rate of reaction means the speed with which the reaction occurs. There are multiple reactions. Some reactions occur slowly, some reactions occur fast, some reaction takes intermediate time, neither they are very slow nor they are very fast, but intermediate time. So those examples also we will consider to understand the rate of reaction and how to express them in terms of concentration, change in concentration of the reactants or change in concentration of the products. The third part, we are going to look into distinguish between elementary and complex reactions. So there are various reactions as I told you. So we'll look into that. We will also come under understanding two more terms, molecularity and order of reaction. What do you mean by molecularity? What do you mean by order of reaction? And what is the difference between these two terms? Then we are going to define rate constant. What do you mean by rate constant? How does it impact a chemical reaction? Does it have any effect on it? We are going to look at the factors affecting rate of reactions. Now, what do you mean by rate of reaction? The speed of reaction. What could be the factors affecting the speed of reaction? Let me give you one simple example. So, say for example, if I've kept a vessel filled with water in an open sunlight environment, what is going to happen? So obviously the answer is that evaporation will take place on its own, but evaporation does not take place on its own, right? There is heat, there is temperature requirement, and there is the surface requirement, because we've seen that evaporation is a surface phenomenon. So greater the surface, the evaporation would be faster, isn't it? That is the reason that on this entire Earth's surface, we have approximately 70%, 71% ocean. God knew that natural evaporation process is needed, and evaporation, since it's a surface phenomenon, there is a huge surface requirement so that cloud formation can take place and we can get drinking water by means of rains. So 70-71% is ocean because the larger surface area, and so the rate of evaporation is higher. So rate of evaporation, that is the speed with which the evaporation takes place, that is going to be completely dependent upon the surface. Greater the surface, greater the rate of evaporation. It will depend upon temperature as well, because if the temperature is high, the rate of evaporation is going to be high. So these are the factors that affect the rate of reaction, and those factors we are going to discuss in detail for every type of chemical reaction. Concentration, temperature. Certain reactions takes place in the presence of catalyst. You know what I mean by catalyst? These are all basic fundamental concepts that you should know before we start with chemical kinetics. A catalyst is a chemical substance that do not participate in the reaction, but it helps in altering the rate of reaction. That means certain reactions which may not proceed at the given rate, we involve a catalyst in it. So catalyst does not participate in the reaction, means it will not react with any other chemical component of the reaction, but it will help to speed up the rate of the reaction. That is a catalyst. We are going to look at factors affecting the rate of reactions, as I discussed: concentration, temperature, catalyst, etc. And then we are going to come across two different types of reaction: the zero order reaction, the first order reaction. What is it? This is a new term for you. So we are going to look into it and derive the integrated rate equations. So mind you, you need to have a pretty good knowledge about integration. That is your calculus part of mathematics. To understand, some amount of calculus knowledge needs to be there in order to derive the integrated rate reaction for zero order and first order. Lastly, we are going to understand rate constant for zero and first order, and also describe the collision theory. What is collision theory? That we are going to look into chemical kinetics. So I hope the objectives are now since very clear. So now we need to understand, what do you mean by chemical kinetics? I hope the answer must be there with you, right? So let us see what is chemical kinetics. So let's now understand what is chemical kinetics. Chemistry by nature itself is change, something that changes. So when we are taking any reactant to react with each other with a particular set of property, it will form another product with a different set of property. That is called as a change in a chemical reaction. But for any chemical reaction, what do the chemists try to find out? Number one, they will try to find out the feasibility of a reaction. Feasibility of a chemical reaction. Now, what do you mean by feasibility of a chemical reaction? That means that whether a particular chemical reaction will occur, will not occur, how much time will it take to occur, what would be the quantity of the products obtained, and whether the reaction is really feasible or not. See, quantity and all comes later stage, but then the actual meaning of feasibility of the reaction is that whether the reaction is possible to happen or not. And as per thermodynamics, we know that when delta G is less than 0 for a given temperature, at constant temperature and pressure, when your delta G is less than 0, the reaction is feasible. So delta G less than 0 at constant temperature and pressure, I can say that the reaction is feasible. That means possible. The reaction is possible if your delta G is less than 0 at constant temperature and pressure. This is as per thermodynamics, okay? That's your thermodynamic topic which you come to across. That is as per thermodynamics. Secondly, what do we try to find out? What do chemists want to know when we come to regarding the chemical reaction? So it is to the extent to which a reaction will proceed. The extent to which a reaction will proceed can be determined by understanding the chemical equilibrium. Now what is chemical equilibrium? By determining the chemical equilibrium. So you need to know what you mean by chemical equilibrium. You must have done your ionic equilibria topic very well. So an equilibrium is, so your rate of forward reaction is equal to rate of reverse reaction. That is nothing but is a chemical equilibrium. And so with that, determined by chemical equilibrium. Okay, so the extent to which a reaction will proceed, that can be determined with the help of the chemical equilibrium. And thirdly, we need to find out what is the speed of a reaction, right? That is the third point that we need to consider, the speed of a chemical reaction. With which speed the reaction takes place. That means the time taken by a reaction to complete. Now, what do you mean by complete? See, there are many products that we require, for our day-to-day life, also for medicinal purpose, for multi other purposes. So, in every chemical reaction, for every product formation, it is very, very important for us to know how much time will a reaction take to form that particular product, what quantity of reactants will be used, what quantity of product will be formed, and accordingly only can we control that particular rate of reaction or not. So according to that only we can proceed with a particular chemical reaction. So that is what, the feasibility and extent is very important for any chemist to know and understand a particular chemical reaction. So example, if I say the parameters like, to design. So to design something like how rapidly your food will get spoiled, or when you go to a dentist, to do the dental filling. Sometimes, you must have gone with your parents or grandparents to do the dental filling. So the cement that they are using, that is also chemical only. Now just imagine when they fill that cement and immediately that cement falls down, right, without getting solidified immediately, then it won't work at all. So we need to have such a material which should immediately get filled up in your dental gap and get solidified, right? So we need to know that what is the rate of the reaction, what kind of chemical component can we use. Immediately, second example let us take. So people say diamond is forever, right? So you can see a lot of ads with those who are selling diamond jewelries and diamonds. They say diamond is forever. But as a chemist, as a scientist, as a professor, or as an educator, I would say that diamonds are not forever. Why? Because you know and I know, since we are studying science, that both diamond and graphite are made up of carbon. They are allotropes of carbon, right? So it's but obvious that graphite has got its own features, diamond has got its own feature, but one day diamond will turn to graphite because of external conditions in which the diamond is kept, right? And that diamond, when it gets converted to graphite, so then it cannot be called as diamond forever. It could be called as like diamond made for each other, for husband and wife, for some time period, 25 years, 50 years probably, but not more than that. So diamond will get converted to graphite, right? But that process is so slow, because it takes time for a diamond to get converted to graphite, right? And that is why they keep on saying that diamond is made forever. If I am an educator, I would say diamond is not forever, gold is forever. So if you want to invest any time, any money, anywhere, invest in gold. Thousands and thousands of years, millions and millions of years, gold will keep on inflating its rate, and gold is going to be forever. So please invest on gold. But let's get back to our lecture of chemical kinetics, and that is what are the three most important conditions to know about a chemical reaction. And this also now defines the meaning of the word kinetics. So if I want to say kinetics, this particular word has come from a Greek word kinesis. Kinesis mean movement. Whose movement? Not my movement. Okay, I keep moving a lot during my lecture hours, but it is chemical movement. the movement of molecules, because when chemicals react, there is movement of molecules, there is intermolecular attractions, and accordingly the products are formed. So kinesis means movement and chemical means that. So I can say chemical kinetics means movement of chemicals. Chemical kinetics means movement of chemicals. That explains you what do you mean by chemical kinetics. Now besides this, there is one more part what we are going to deal with. The most important part is average rate and instantaneous rate. So in this chapter, how do you define average rate and instantaneous rate? Now let me give you a very simple example. All of you must have come down, sometimes you must have gone to Delhi or Mumbai, and when we go to visit places, like in Delhi we have India Gate, in Mumbai we have Gateway of India. Okay, so both are kind of reversed names. Okay, so when you want to visit such a particular place by car, and say for instance that distance is around 30 kilometers from your home, when you are traveling to India Gate or Gateway of India in Mumbai, right? It's about 30 kilometers you want to travel, and your car took around 1 hour to reach that particular location, right? So during this entire time, your car took 1 hour to reach that location, to cover up a distance of 30 kilometers. So the speed of your car comes to 30 kilometers per hour, right? And anybody asks you what was the speed of your car, you'll say 30 kilometers per hour. But tell me, my dear friend, throughout the journey of that 1 hour, right from your home to India Gate or Gateway of India, did your car travel at a constant rate of 30 kilometers per hour? Means there was no traffic, the road was all clear, and still you were driving at nice 30 kilometers per hour, slowly enjoying the scenic beauty outside. No, I want to drive very slow and I need to go slow, so my car is going to drive slowly at 30 kilometers. Isn't it? Is it? No, obviously not. So there was traffic, there were people, there were turns, there were rounds, circles, everything was there in your journey. So at some place, your car might have traveled at a speed of 80 kilometers per hour. And at some place, when the signal light came in and the RTO officer showed you stop, right, your car speed must have come down to 0 kilometers per hour as well. So the 30 kilometers per hour what you are talking about is not the speed of the car. That is called as the average speed of the car, right? Average speed of the car. But if I ask you that you left your home at 10 o'clock, you reached that particular destination at 11 o'clock, what was the speed of car at 10 hour 11 minutes? So at that 10 hour 11 minutes, whether you were halting at a signal or whether you were taking a turn or whether your car was on a clean road and at a speed, you need to identify that, and that time, whatever was the speed of the car, that will be called as the instantaneous speed of the car. That means the speed at that moment. So in chemical reactions also, both average rate and instantaneous rate are the same kind of features, because when a chemical reaction proceeds with a speed, right? So when we say that this particular chemical reaction took an hour to complete, that is the average rate. But I will try to find out during that 1 hour, at every instant, what was the rate of a chemical reaction. Probably in the beginning portion, that is in the start of the reaction might have proceeded at a faster rate, then it might have slower down, or initially the rate of reaction was slower, then because of the conditions it went to a faster rate, so the graph would change accordingly. That is what is average rate and instantaneous rate we are going to understand in this topic of chemical kinetics. That is all about the introduction of chemical kinetics, and I hope I was an entertainer, educator for you to make you understand what is chemical kinetics. Enjoy this topic, learning on your own. You don't need the lecture every now and then, you can do some things on your own. Today's date, when you take up a mobile phone and install any particular game, do you need a teacher to teach you? You get into it and you learn everything. So get into your textbook, love chemistry, and then see how beautiful is chemistry. Thank you. Have a nice day.